So I'll just start with a bit of introduction about IgA nephropathy. It's the most common primary glomerulonephritis worldwide, with an incidence of around one new diagnosis per 100,000 people per year in developed countries. The prognosis is quite variable, with 30 to 40% of patients progressing to end-stage renal failure within 20 years of diagnosis. And at present, there's no way to tell how the disease will progress at that diagnosis. The disease itself is characterized and indeed diagnosed by the observation of IgA and IgA immune complexes deposited in the renal mesangium, in particular in the glomerulus, which you can see in the left-hand picture there. This IgA is normally of the IgA1 isoform, which, as opposed to IgA2, contains an extended hinge region between the variable and constant regions here. And this hinge region has several sites for O-glycosylation, and patients with IgA nephropathy have IgA1 with reduced galactose at this hinge region. This has been found both in serum and isolated from mesangial deposits. So there's a proposed mechanism behind the complexities of this IgA nephropathy disease. Circulating galactose-deficient IgA1, combined with the production of anti-IgA1 antibodies, leads to the formation of immune complexes, which are then deposited in the kidney, causing local immune activation, cytokine and chemokine release, and general kidney damage, glomerulosclerosis, and interstitial fibrosis. So a variety of pro-inflammatory cytokines, immunoregulatory cytokines, and growth factors have been shown to be elevated in IgA nephropathy patients. This could be due to the release of cytokines from the IgA deposition in the renal mesangium, or it could just be in general, we're not sure. And also an interesting side note is that several Th2 cytokines such as IL-4 and IL-6 have been shown to downregulate the galactosylation of IgA1 in vitro experiments. Also, the differentiation of naive B cells to IgA memory B cells and IgA secreting plasma cells is highly regulated by a large variety of cytokines, whether it's activated by in a T-cell dependent fashion by CD40 or independently of T cells through activation by soluble BAFF and APRIL in circulation. So as I said before, the only way to diagnose this disease at present is with a renal biopsy. This is quite invasive, so there's a strong need to find any potential biomarkers that can be used to identify this disease. So for this, we were looking at serum biomarkers in IgA nephropathy, and we're looking to assess any relationship these biomarkers could have with renal function in general, as well as IgA nephropathy itself. So to this end, we selected 32 cytokines from the custom assay developing tool at R&D Systems. These were chosen based on relationships with roles in B and T cell activation, maturation, any involvement in the direct synthesis of immunoglobulins, in particular IgA, and whether there was any reported involvement in other glomerulonephritis and IgA nephropathy itself. So the UK glomerulonephritis DNA bank contains samples from a large number of patients with various glomerulonephritis, including IgA nephropathy, and also has a large variety of healthy subjects to choose from as well. So for this, we've selected the IgA nephropathy patients, healthy subjects, and as a disease control, we chose membranous nephropathy patients, which is another autoimmune-mediated glomerulonephropathy, similar to IgA, but without any IgA involvement in the kidney. For this study, we split into two experiments. The first was normal renal function, with a serum creatinine level of less than 110 micromole per litre. And we had IgA nephropathy patients, membranous nephropathy patients, which were matched for serum creatinine with the IgA patients, and healthy subjects, which were age-matched to the IgA patients, and there was 89 of each of these groups. The second experiment was impaired renal function. All the serum creatinine was greater than 110 micromole per litre. IgA nephropathy patients, membranous nephropathy patients, again matched for serum creatinine with IgA, and healthy subjects, again age-matched, and there was 20 in this group. Now, all of the samples were then randomised completely and run on the Luminex assay plates that we got. So for the results in general, 7 of the cytokines that were analysed here were found to be below the lower limit of detection in this particular assay. GM-CSF, interferon gamma, IL-7, IL-12P70, IL-15, IL-17A, and IL-22. a further 15 were shown to have a significant correlation with renal function, either in IgA nephropathy or membranous or both together. So to break that down a little bit more, these 7, so uteroglobin, TNF receptors 1 and 2, FAS, CD30, IL-18 binding protein A, and CD40, all correlated with renal function in both IgA nephropathy and membranous nephropathy. Further on from that, CD27, BCMA, CTAC, APRIL, IGF-BP1, and TACI only showed significant correlation with renal function in IgA nephropathy patients. And finally, for this section, the CD163 and IL-1 receptor 1 only correlated with renal function in membranous nephropathy. So to start the results for normal renal function experiment, only these 3, BCMA, TNF receptor 1, and MMP2, were elevated in IgA nephropathy compared to healthy subjects. And as you can see, they were also elevated in membranous, and a further 17 only showed elevation in membranous nephropathy compared to healthy subjects. And I won't go through that list because it's a bit long. So with the results of the impaired renal function experiment, 10 cytokines were elevated in IgA nephropathy and membranous nephropathy. The first 5 on the list are CD27, BCMA, IGF-BP1, TRAIL, and uteroglobin. And the next 5, CD30, APRIL, TNF receptor 2, IL-18 BPA, and TNF receptor 1. Now, we found a single cytokine, CTAC, that was elevated only in IgA nephropathy patients compared to healthy subjects, and this was with impaired renal function only. And a further 7 cytokines were only shown to be elevated in membranous nephropathy patients. So previous studies of this nature working on biomarkers in glomerulonephritis have failed to correct for renal function when looking for associations with these diseases, either not at all or with very minimal correction. This could mean that the elevated levels of these biomarkers simply relates to a decreasing renal function. So basically these assays would just be looking at an expensive measure of declining renal function. However, we've shown that there were some cytokines that have disease-specific correlations. Now, this could imply that there's some sort of relationship to the causation of the renal decline rather than simply a symptom of it. We've got a panel of cytokines that we'd like to work on further, with only CTAC showing specificity to IgA nephropathy. And in a future work, we'll look at longitudinal studies to examine any impact these have on disease phenotype and response to therapy. I'm sorry this has been quite a brief talk, so I'd just like to thank the organisers for inviting me to speak here, and all my funders for giving us the ability to do this work, Biotechne for supplying us with all the assays that we used and giving us all the same lot number, which is key for this, and all of my colleagues at University of Leicester for their support in doing this study. Thank you.